So I'm going to take you through how to balance this equation, okay? We have two reactants on the left and one product on the right. We have one atom of iron. Iron has the chemical symbol Fe, and metals will always be symbolized by just one um, atom of its element, okay? So Fe just means there is one atom of iron. O2, O is the symbol for oxygen, and 2 after the O means there are two atoms of oxygen. And then Fe2O3 is iron oxide. And there are for every two atoms of iron, there are three atoms of oxygen. Now, how do we balance this? That's the question. Well, number one, we cannot change these small numbers. I can't just change that 2 to a 3 and then put a little 2 next to the Fe. It does not work like that. Okay, you cannot do that. What you can do is add big numbers in front of these substances. When it comes to balancing equations, you have to have the same number of atoms on the left-hand side and the right-hand side. Atoms are not created or destroyed. Okay, law of conservation of mass, they are only transferred. We can use these particle diagrams to represent what is there in the chemical equation. Okay, circles represent the atoms with the symbols in the middle. Now, what we're going to do, we need to make the number of oxygen atoms on the left equal the number of oxygen atoms on the right. A tip before I go on is that if you ever have a symbol such as Fe or another metal element by itself, always leave that until the end. That's always the easiest thing to balance. So 2 and 3, they both need to go into a number. What number do 2 and 3 both go into? In the chat section, please. 6. Excellent. Well done. 6. Excellent. Oh, it says you're still arriving. Sorry, Safa. I hope you can hear me. Well done. They both go into 6. So therefore, what number should we put in front of the O2? What number should we put in front of the O2? Excellent. 3. Of course, we put a 3 in front of the O2. What number do we therefore put in front of the Fe2O3? Excellent. 2. Exactly. So we put a big 3 in front of the O2. And a big 2 in front of the Fe2O3. Now, a technique that we can use to count the number of atoms underneath is this technique here. We write Fe, O, and then FeO. These are the elements and the number of atoms. Now, when we put a big 2 in front of the Fe2O3, this multiplies whatever we have by 2. So that's super important to understand. We multiply whatever is there by the number in front. Now, this is really simple mathematics, simple numeracy. 2 times 2 means there are 4 iron atoms. 2 times 3 means there are 6 oxygen atoms. Chemistry, the maths in chemistry is actually really easy. It's just about remembering what to do. That's what makes it difficult. We can now see there are 4 atoms of iron on the right and 1 atom of iron on the left. There are 6 atoms of oxygen on the right and 2 atoms of oxygen on the left. We then need to put a big 3 in front of the O2. Okay, you can see they're not balanced as I was doing there, which means there are now 3 moles or 3 molecules of oxygen reacting. Okay, we can clearly see there are 6 atoms of oxygen. And as I said, the easiest bit to always do is the last one, when you have an atom by itself. 4 atoms of iron, because we put a big 4 in front of the Fe, and that's how we balance chemical equations, okay? I hope that was okay. We're going to do one more because balancing equations is important. We're going to go back a step. We're going to go back. Not this one, not this one, not this one either. This one. Off you go. You could get a question like this, 2 marks in an exam. Go. I'm going to give you 45 seconds. 3, 2, 1, and let's see what we got. Oh, it's not that one. It's not CH4 plus 3. Oh, have you balanced that? 8. No, it's not there because look, you've got 4 hydrogen atoms. You put a big 4 in front of the H2O. Well done, excellent. No, that's not correct, Abisham. No, because look, you've got 2 oxygen atoms here, and then 2 times 2. And it's H2O. It's not HO2. I'm going to show you. I need to charge now. Okay, so look, this is what it is. Okay, we put a big 2 in front of the O2 and a big 2 in front of the H2O. Why? Because look, there are 2 atoms of oxygen on the left and there are 3 atoms of oxygen on the right. 1 atom of oxygen and then 2 atoms of oxygen. Add them up together, that's 3. Now, what we need to do is we put a big 2 in front of the O2 on the left and then a big 2 in front of the H2O on the right, over here. Another way of thinking about this is there are 4 hydrogen atoms on the left and 2 hydrogen atoms on the right. To put a big 2 in front of the H2O would mean you do 2 times 2, so 4 hydrogen atoms, which balances the 4 hydrogen atoms on the left. That's another way of looking at it as well. And then look, the carbon atoms, 1 carbon atom on the left and 1 carbon atom on the right. That's already balanced. Now, at the end of this video, there are loads and loads of balancing equations that you can balance, followed by the answers. To be honest, you can find a lot of balancing. You can find a lot of symbol equations to balance on the internet. So we're not going to focus on that. Let's now move on.